Hey guys, and welcome to our first lesson of section 7.3, which is multiplying and dividing rational expressions. Before we actually get to multiplying and dividing, we're going to learn how to simplify rational expressions. So our first learning target is I can simplify a rational expression. Now, if you don't remember, a rational expression is a fraction whose numerator and denominator are non-zero polynomials. The domain of a rational expression excludes the values that make the denominator equal 0. And I hope you remember that from when we did that when we were graphing rational expressions. A lot of times we'd have a vertical asymptote at those values. Okay, a rational expression is in simplified form when its numerator and denominator have no common factors other than plus or minus 1, which happens with every number. Okay, so before I move on to actually simplifying rational expressions, I'm going to simplify a fraction, just numbers. So let's say I have 25 over 45. Okay, now we can definitely reduce this fraction, and the reason we know this is because they have a common factor, these two numbers, of 5. So I could rewrite this fraction as 5 times 5 over 5 times 9. So this allows us to cancel out the two 5s that these two numbers have in common as factors, and then the 5 over 9 is the simplified version. So 25/45 is actually 5/9 in simplified form. Okay, so the steps that I followed there are actually the same steps you're going to do when simplifying a rational expression. The first thing you're going to do is completely factor the numerator and denominator, and that's what I did when I rewrote 25 as 5 times 5 and 45 as 5 times 9. And then we cancel out any common factors. The only thing that we add into when we simplify a rational expression is that we identify any excluded values. So here we go. Example 1. Simplify each rational expression. Identify any excluded values. So letter A, I have 4x plus 12 divided by x squared plus 6x plus 9. So 4x plus 12, I can factor out a greatest common factor of 4 from both of those terms, which leaves me with 4 times the quantity x plus 3. X squared plus 6x plus 9 is a trinomial that factors 2 x plus 3 times x plus 3. And now we can see that the numerator has one factor of x plus 3, while the denominator has 2. So we can only cancel out 1. And what we are left with is 4 over x plus 3. Now, to identify our excluded values, we look at the original expression and find the zeros of that denominator. So because both these factors were the same, the only value would make those equal 0 would be negative 3. So x cannot equal negative 3. So we just have one excluded value in that case. Okay, moving on to B. X squared plus 7x over x squared. Okay, a common misconception is that when you see something the same in the top and bottom of a fraction, you can cancel it out regardless. So a lot of people would want to look at this and say, oh, I'm going to cancel out x squared. But that's actually illegal. You cannot do that unless if it was written as, let's say, x squared times 7x over x squared. So it must be in factored form in order to cancel anything out. So I'm going to go ahead and just erase that because that is illegal. I need to do step 1, which is factor. So in the numerator, I can take out an x from both of those terms, which leaves me with x times x plus 7. In the denominator, I can write x squared as x times x. And now I see that I have a common factor of x in both the numerator and the denominator. I can cancel those out. I'm left with x plus 7 over x. And looking in my original denominator, the only value that would make that equal 0 would be 0. So x cannot equal 0. I just have that one excluded value. Okay. Finally, I have x squared minus 4x minus 12, over x squared minus 4. Okay, so I'm going to start by factoring the numerator. This trinomial, what factors of negative 12 will give us, when we combine them, negative 4. And that would be a negative 6 and a positive 2. The denominator x squared minus 4 is actually a difference of squares binomial, which factors to x plus 2 times x minus 2. Now, we see we have a common factor of x plus 2 in the numerator and the denominator that we can cancel. And we are left with x minus 6 over x minus 2. We actually still have to account for the two excluded values from before we cancel anything out. So actually x cannot equal plus or minus 2, even though we canceled out that factor x plus 2, which gives us that excluded value of negative 2. All right, guys, that is simplifying rational expressions.